and welcome back to module number 5. And this time again I am taking a step backwards with regard to our progress with R. And one of the things that is really important is to fully understand the idea of hypothesis testing. And I add to this module a little bit correlation and regression in order for us to add more context to it, but our textbook does not specifically address the idea of hypothesis testing. It doesn't allow us to see what it is entail. So I, as experienced instructor to statistics and in R, one of the things that we have to remember, always to remember, is to how to conduct the hypothesis testing. So this module is about that. It's basically a little bit review of some of you already know hypothesis testing, and to those who do not, this is a great introduction to it. So, and the reason for that, these textbooks always rely on hypothesis testing. So we will review the hypothesis testing procedure, the idea of it and the procedure that we will take, and then we will do some correlation or regression where we will come back to it later on. So in the first module, I talked about population and a sample. And the idea was that in population, it is all possible values. And in a sample is we take a proportion of the sample and try to make a predictions about the population. And the idea here is that two forms of statistics usually associate with population or a sample. Is this the hypothesis testing and the estimate if a sample represent the population. So with that regard, we need to be careful and need to be sure that we have the main characteristics of the population in the form of the mean. And we also need to calculate the data from the sample with regard to the sample mean of the data. And so we will use that in order for us to estimate is estimation of the sample actually correlate to the entire population. So the steps in hypothesis testing. Again, there is a lot of ways to do that. This is the standard way. This is the traditional way to think about that. There is the null and alternative hypothesis. There is the test that involve in it, and there's the p-value and its interpretation. And there is also lately more and more people use the significant level as alternative in order to test the validity of the hypothesis testing. So what is this hypothesis testing that I've been talking about? It is a statement that determines whether a statement about the value of population should be or should not be rejected. I know it's a little bit confusing, and I will try to explain that in 2 seconds with a real example. But we have a little bit understanding what it stands for and what is the terminology. The null hypothesis, usually denoted by the H0, is the assumption about the population. The alternative hypothesis is the opposite to the null hypothesis. So we have HO and HA, and the HO is the null hypothesis, the HA is the alternative. And we need to show or determine which one is the true about the population and true about our sample in order for us to verify it. It is not always obvious how the null and alternative hypothesis should be formulated. The context of the situation is very important in determining how the hypothesis should be tested. And this is something that is really a craft by itself. And so in some cases, it's easy to identify the alternative hypothesis first and in others is the null. So the alternative hypothesis as a research hypothesis, many application of hypothesis that involve the attempt to gather evidence in support of the research hypothesis. And the conclusion of the research hypothesis is true is that it made it if the sample data sufficient evident to show that the null hypothesis can be rejected. So if we are rejecting the null hypothesis, that's way we can say that alternative is true. So, example, a new teaching method is developed that is believed to be better than the current method. So the alternative hypothesis, the new teaching method is better. The null hypothesis, the new method is no better than the old method. And then again, look at the wording, the selecting words that I use in order for me to describe alternative versus the null hypothesis. The idea of developing the alternative research is, example, a new cell force bonus plan is developed in an attempt to increase sales. So again, the alternative came first, and in this case, new bonus plan increase sales. The null hypothesis, the new bonus plan does not increase sales. And those are the example of it. And again, look at those examples and see if it makes more sense. But we need to be more concise with regard to our statement, which means that the label of a soft drink bottle states that if it contains 76.6 liquid ounces, we will state our hypothesis. The null hypothesis is correct, and it will be smaller or bigger or smaller or equal to 67.6. The incorrect, the label is incorrect, and it will be smaller. And look at the titles and the measurements that I put into it in order for me to make it easier for me to apply. So the idea here is the population of the mean. The mean is usually the sum of the value divided by the number of value, if possible, are equal. So the sample, the population and the sample mean, collect the data, sum all the value in the population versus the sample, divide the sum by the number of elements in the population versus. So in this case, we are trying to set up a form to verify our hypothesis. And in this case, we have one trail, two trail, one trail upper trail, one trail lower trail, and two trail. So in this case, is that the hypothesis testings about the value of the population mean must take one of the following three forms. And where the null hypothesis is the hypothesis value of the population means. Also, again, I'm adding those structure into my hypothesis procedure in order for me to verify it. So the null and the idea is that it's smaller or equal. The emergency serving is meeting up the response goal. No follow-up action is necessary. And the alternative, the emergency service is not meeting the response goal. The appropriate follow-up action is necessary. So in this case, the mean response time for the population of medical emergency requests. And again, this is the structure that we need to follow. But with that, we have also some errors. Most common error is type 1 error. Because hypothesis testing is based on a sample data, we must follow the possibility of error. Type 1 error is rejecting the null hypothesis when it's true. the probability of making a type 1 error is when the is true as equally is the level of significance. Application of the hypothesis testing that only control the type type 1 error are often called significant test. Significant type 2 error is called when we accept the null hypothesis when it's false. So it is difficult to control the probability of making the type 2 errors, and so with that, statisticians avoid the risk of making type 2 error by avoiding to not reject the null hypothesis or not accepting the null hypothesis. So this is the population and the conclusion in that regard. So again, accepting correct decision but can be false in type 2 error in the second case, and reject the null hypothesis type 1 error when the null hypothesis is true, but when it's false, it is the correct decision. Now the p-value come into play, and the p-value is the probability when computing using test statistics that measure the support or lack of support provided by the sample for a null hypothesis. So the p-value is less than or equal to the level of significance. So the level of test statistic is the rejection region. Reject the null hypothesis if the p-value is equal or smaller than the big then. So in this case, the guidelines for providing interpretation for the p-value less than 0.01, overwhelming evidence to conclude that the alternative hypothesis is true, between 0.01 and 0.05, strong evidence to conclude that alternative is true, and between 0.05 and 0.10 is also, we are concluding that is weak evidence that the alternative hypothesis is true. Greater, that we will say that there is insufficient evidence to conclude that the alternative is true. So this is part of what we are aiming to do when we are trying to interpret the p-value. And so the idea here is that we need to say where we are with regard to the sample distribution with that regard. The upper trail test about the population mean with regard to the p-value, again, where the p-value stands with regard and how it plays out. So the critical value approach to one test trail hypothesis is that when the test statistic Z has the standard normal distribution, we can use the standard normal probability distribution table to find the Z value. The R can do that for us with the area of the lower trail of the distribution, something that the R also can do. So the value of the test that established the boundary of the rejection is called critical value of the test, and that's where the rejection rule is lower trail and upper trail in order for us to verify it. So in this case, the green color is no rejection, the red color is the rejection of the null hypothesis. And the upper trail of the test, again, is where it comes into play, and where we reject the null hypothesis is color in red. So I'm back to the procedure. This is really important because you will see that in R, and R will be able to produce it. So the first one is more theoretical, that it's depending on you. You need to determine the null and alternative hypothesis. It is a statement, and the more accurate you are in your statement, the better you are with verifying this information. Then you have to specify the level of significance and then collect the sample data and compute the value of the test statistics. The p-value approach is that it's step 4, use the value of the test to compute the p-value, and then step 5, reject the null hypothesis if p-value is equal or smaller than the result. The steps in, again, the idea of how, I'm repeating, I know that I'm repeating myself, but I want you to have a coherent way to recognize it and to value it. And let's take an example. This is a trail test about the population mean, and we are talking again about emergency medical services and the response times of a random sample of 40 of medical emergency with tabulate. So the sample mean is 13.25 minutes. The population standard deviation is to be 3.2 minutes. So the director of this emergency service wants to perform hypothesis testing with a 0.0 level of significance to determine whether the service goal of 20 minutes or less can be achieved, and this is quite possible. So if we look at the standard, is that we are trying to determine the z-value, and we are doing that by computing the mean and the standard deviation, and we are trying to compute how we're going to apply that. So we're developing the hypothesis, we are stating it quite clearly, we determine the 0.05 as a level of significance, and we start testing it in order for us to verify it. So the idea here is, again, based on what I have said, this is where we are computing 1 minus 0.9932, which is equal to 0.0068, and we are able to determine to reject the null hypothesis. This is the procedure that we often use in the old days with regard to how we are applying to it. But I want you to have a clear sense, because from now on, when we're going to the more advanced module, we are going to see that the procedures are already embedded into our calculation in R. And so again, I want you to feel comfortable in doing so. I give you some example of one trail test about the population mean, known as S, and again, this is how we will do that. And in this case, I will calculate the same calculation. I will calculate the X bar, which is the sample mean, it's 13.25, and the hypothesis value, and the sigma, the population standard deviation, and the sample size will be 40. So in this case, Z is equal to Z bar minus the mu, 0, divided by the sigma A, divided by square root of n, in order for us to do that. So in this case, we came up with the idea of the value of the Z, and now we can actually calculate the critical value of significance of 0.05 level, and in this case, it will give us the Z critical value is minus 1.6449. So again, the idea of how to approach it and how to apply it in that sense. To compute the p-value in the following, in the 3 steps, to compute the value in another example, 2 trail hypothesis, to compute the value of the test statistical z-score. If the z is in upper trail, is bigger than 0, we compute the probability that z is greater than or equal to the value of the test statistic. If z is lower, we compute the probability that z is less than equal to the value of the test stat. So step number 3 is the trail area obtained in step 2 to obtain the p-value and then reject the row if those value. So those are the critical values that we often use in order for us to do that. Test about the population mean. So the idea here is that test statistics has t-distribution. T-distribution, we will talk about t-distribution in the following module when we're going to talk about that. But we also have to add the n-1 degree of freedom. And so the idea here is that the test about the population with regard to the test hypothesis is that if we reject the null hypothesis, if t-test is smaller or equal to minus t in the square root of the q. So the idea is this is part of our terminology in order for us to do that. So in p-value and the t-distribution, in probability, the t-distribution is any number of a family distribution that traced when estimate the mean of normally distribution population, where the sample size is smaller and the population standard deviation is unknown. So the format of the t-distribution, again, the format of the t-distribution table provided us in most textbook statistical textbooks. In our textbook we do not have that, but again we can take advantage of the R with regard to p-value and its distribution. With one trail test about the population when it's unknown, and again this is how we compute this and how to formulate that in that relationship, and one trail test about the population when it's unknown. Again, this is where we come up. This is the old way of doing that. So this is part of the summary of the population. This is part of what we will see throughout the semester when we are testing our hypothesis with the t-distribution. We will talk about that, and again this is a teaser, so you will have more context when we are talking about that in the following chapters. And test about the population proportion, again this is the assumption about that and how it be done. I summarized that procedure and the decision-making steps, so you will have it in writing, so you will have known what has happened and how to imply that. I'm jumping again, this is not chapter 12, but I'm going to talk about, this is for my own textbook, going to talk about correlation coefficient, person product movement correlation, measurement of correlation, introduction regression, and the least square regression, in order for me to give you some context. And again, going back forward or putting it forward, we will see that. One of the most common form of statistics is correlation. It's the idea of a single number describe the degree relationship between two variables. Let's work one example to show how it's compute. So the idea here is that we are using correlation coefficient between +1 and -1. So the value is that the correlation coefficient values goes towards 0, and the relationship between the two variables will be weaker. Usually in statistics, we measure 3 types of correlation: person correlation, candle rank correlation and Superman correlation. Each one of them has its own value in all attributes. So correlation analysis to measure the strength associated with linear relationship between two variables. There might be correlation is only concerned with the strength of the relation. No causal effect is applied with the correlation. In regression, which is a next step, is predict the value of the independent variable based on the value of at least one independent variable, and which explain the impact of changes in the independent variable on the dependent variable. So the dependent variable is the variable we wish to predict or explain. The independent is the variable we use to predict to explain the dependent variable. So the idea of the correlation coefficient is to measure the strength of the linear association between the variables. So the best way to look at person production moment correlation is the form of correlation coefficient. So we often use scatter diagram to display which order pair of measurements can be plotted on coordinate axis system. So the dependent variable is expressed by horizontal axis. The dependent variable is the vertical axis. So the point representing the data usually plot either by dots or crosses. So this is example height versus weight, and this is where we see if there is a correlation between them. The person product movement correlation coefficient is the numerical value of the degree associated with the two variables by a given product movement correlation, and the index provides measurements in the context at which the two variables associate. So the value of the correlation coefficient is calculated from bivariate data, bivariate meaning that it consists of two variables only, by means of a formula that involves the data points. And we are using the R, the letter R, into the value of the correlation coefficient in order for us to come up with the result. And the P value, or the letter, comes from the population, and it is part of what we do. So the person product movement correlation is the value of R, and this is how we calculate it, where we apply that in the following formula, where R is equal to S and the S squared with two values XX and YY, and where we can break it down where we calculate those values. The person correlation movement is where the X, the standard deviation, the SY is the standard deviation of the Y variable, and the N is the number of observation. The alternative formula for correlation of R in this case is the following. So note that the value of R always lies between -1 and 1, and if it's +1, the two variables have almost the perfect positive correlation. When they are minus, have perfect negative correlation. If the two variables are positive but not perfectly so the coefficient lies between 0 and 1. If the two variables have no overwhelm upward or downward tends, it tends to be 0. Positive and negative, again, with that regard, and this is how it lay out for us with that regard. This is the negative correlation, and again, this is in this class we will see an example and how to apply that. In this case, what is the value is how it been done. Another form of calculation is the Superman rank correlation, whereas the D is the difference between the corresponding pair of ranking, the N is the number of pairs of observation, and in this case we have determination of the RS and +1 and -1, and that where we can evaluate in that. In R, we usually do core.test, which is we put on the quotation the X and Y, the method, and in this case we can define person, Kindle, or Superman can be abbreviated. And another form or another function, we have the confidence.level, which is the return value of the confidence level. Example, we have the X with a sample plus a random normal distribution of 10 and a standard deviation of 2, and we will say that Y, and in this case I will bring what I have found with that regard and I will add it to the D. I will use the data frame in order for us to do that, because we have three values, the X, the Y, and the Z, in order for us to do that. And here it is the result of it and how it will play around. This is the summary of our analysis. Correlation in R is again very simple. It is the idea that you will type what type you want, the candle and Superman. My recommendation, my personal recommendation, always use more than one, just to make sure that you are correct and you get the result of it, just to see where your distribution lies. So I summarized the idea of the function in R and the default and how to apply to it. And to run the contest, you usually use variable 1 and 2 and the methods, and you can apply that in that sense and how we apply that. We also can use graphic in order for us to correlate things, and we can also add a line to fit best the line analysis, and that's it. So the outline for correlation analysis in R is the following, and I also posted on Canvas. Sorry, my mistake. Where is it? My own test, my own notes for my own book on that subject of correlation. So you'll be able to see that, and my own notes on correlation and regression with that regard, so you can actually see what it is entail if the page will come out. I'm still waiting, but okay, it doesn't come out. Okay, so this is the summary of all my notes and how to apply to it, and this is where my notes in another form. That's it for now. I hope this will give us a better sense to the next chapter in our textbook. If you have any questions, please do not hesitate to ask. I hope the hypothesis module was helpful, so you will have better sense where we are going to start employing the hypothesis part of our calculation in R, so you will have better sense what it is. Until next time, I hope it was good. If not, let me know.